All right, welcome back. Let's do some more examples of indefinite integrals. So remember, an indefinite integral is just a derivative rule written backwards. So for instance, I know that the derivative of the sine is the cosine, so that means the antiderivative of the cosine is the sine, plus c. And I know the derivative of the cosine is minus sine, so if I want an indefinite integral for the sine of x, well, I do minus cosine of x plus c because the derivative of minus cosine x is sine. And all the other trig ones are similar. For instance, I know the derivative, what do I want to do? Tangent of x. Well, that's secant squared. So that means an antiderivative for secant squared is tangent, etc. You can do all the trig ones in a similar way. So every one you know the derivative of, then you know an antiderivative for. Again, you just remember the derivative rules and write them in reverse. What other things do we know? We know things like the derivative of e to the x is e to the x. So here I'm looking for an antiderivative for e to the x. Well, who has derivative e to the x? Well, it's e to the x. All right. More generally, what happens if I add e to the kx? Well, who has derivative e to the kx? So you just kind of think in your head, well, it probably started out as e to the kx, but when I take the derivative of this, that kx is the inside function, and so a k will come out. And I don't want a k over here, so I pre-divide by that constant k so that when the k comes down, it cancels and goes away. So the antiderivative is 1 over k e to the kx, and then that plus c. Okay? All right. Now, because derivatives behave well with respect to sums and constants coming out, we get these rules. First of all, the integral of a sum of functions is just the integral of f plus the integral of g. That's because the derivative of a sum is the sum of the derivatives. And the integral of a constant times f is the constant times the integral of f. Again, constants pull out, but only constants. They're the only things that pull out, just like definite integrals. All right, so this lets us do sort of more complicated looking examples. So for instance, let's do the integral of 5x squared plus 3x to the 10th plus the sine of x plus e to the 4x dx. Okay? So we use these rules just to break this up into small pieces. So it's 5 times the integral of x squared dx, 3 times the integral of x to the 10th dx, plus the integral of sine x dx, plus the integral of e to the 4x dx. Here I just broke up sums and pulled constants out. Now I just ask for how do I find the antiderivatives? Okay. What is a function who has derivative x squared? Well, we know it had to come from an x cubed, but the 3 comes down, and to make sure the 3 goes away, I have a 1/3. Now, an x to the 10th. Well, who has derivative x to the 10th? It had to come from x to the 11th. And the 11 comes down, which I don't want it to, so I divide out by the 1 over 11. So who has derivative sine? Well, the answer is minus cosine of x. Okay? And then, I wrote, I meant to have e to the 4x here. So who has derivative e to the 4x? It had to come from something close to e to the 4x. The 4 comes down. I don't want the 4 to be there in the end, so I divide out. And then finally, it's a plus c. There could be a plus c for each one of these integrals, but since it's a generic constant, I might as well combine them all into one. So just a single plus c. All right, that's it for indefinite integrals. Ciao.